sorry. Okay, here. So we have the back EMF of the motor, which is trapezoidal type. Okay, and our intention is what? Our intention was, like I explained, that this is a back EMF, you see. This is a back EMF, and then it is trapezoidal in nature, and our requirement is that we should inject a current which is synchronized with the flat top portion of the back EMF. This is like this. Just one phase back EMF I am showing here. Okay, like this one. Similarly for other phases will be there. So this is actually requirement. So how to inject this current? We have to know where the rotor is, and how we are getting the information of the rotor position from the Hall sensors. The three Hall sensors are placed with the stator, and they are displaced from each other by 120 degree, and each Hall sensor is leading by around 15 degree, leading by 15 degree from each of the place. Let's say that this is phase A, so you lead by 15 degree. Phase B, so you lead the lead of the 15 degree. This is first coming. You move with the anti-clockwise direction. So which is coming first? Hall sensor. So this lead. Okay. So so we have the three Hall sensors, and why this is happening? That because here we are having a rotor. Here we are having a rotor which is of 180 degree arc magnet. Okay, rotor is of 180 degree arc magnet. This is south and this is north. So when the south pole approaches Hall sensor, particular Hall, it becomes high, and when the north pole approaches a particular Hall, it becomes low. Okay, because this is 180 degree arc, so this Hall will be high for 180 degree duration, and it will be low for 180 degree duration. And similarly then what will happen after Hall A? Hall B will come. So Hall B is coming after what? 120 degree electrical degree. So after 120 degree it will become high, and then again it will become low, and it will remain high for 180 degrees. Like this. So similarly for Hall C. So by this way we have seen that we get to know about the 6 different Hall states. You see, these are the 6 different Hall states. So this is high, low, high, high, low, low, high, high, low, low, high, low, low, high, high, low, low, high. This is continuation. Okay. So you see that 6 different Hall states are there, and these 6 different Hall states identified first in identifying where the rotor is. Okay. And then we have seen what? That you see that this also I explained, like this Hall sensor becomes high where the positive flat portion of a particular phase, let's say phase A. So where this Hall is getting high, this Hall is getting high where the flat portion of the back EMF is getting high, and this is getting low, becoming low where the negative flat portion of the back EMF is there. Okay, it's starting. So we see that it starts from here. Let's say we make a Hall sensor here. I'm making a bit bigger. Okay, so it starts from here and it continue up to what? It will continue up till the negative flat portion. Here is the negative flat portion, and it will continue as a, then it will remain low for the. So this is our Hall sensor. This is Hall A. This is what is the current IA, and this is what? This is the back EMF EA. This is the situation. So likewise we do for all the two. So we have the relationship between back EMF, the current which is required to be injected, which is required to be back EMF, and then we have to know that where this flat portion is starting. So how do we know? We try to find that what is the relationship between the flat portion of the back EMF and the Hall sensor. So we identify these positions. Okay. So we got to know that this position 101 is synchronized with this portion, that 100 is synchronized with this portion. So we know that when the Hall state will be 101, we have to turn on phase A, positive switch. When it is 100, it will be phase A will be positive. And similarly, you go see here, it is current is negative. So phase A switch will be on, but it will be now lower because it is negative current. So where it is, when 010 will be there, lower switch of the phase A will be there. So what is that? It is 1 and 4, 2, 4, 6. Okay. So similarly, in this when it is 011, the lower switch of the phase A switch. So this way we got to the relation. Then I explained you about 120 degree and 180 degree mode of operation. You remember? So what we have done, because this is a 3-phase voltage source inverter. Okay. So what we have seen here is that the circuit what we need to operate is a 3-phase voltage source inverter. So this 3-phase voltage source inverter can operate in 180 degree mode of operation, and it can also operate in 120 degree mode of operation. So 180 degree mode of operation, what we do, that we turn on a switch. Okay, here you see that we turn on each of the switch in the difference of 60 degree. Okay, why? Because there are 6 switches and 360 degree. So 360 degree divided by 6, 60 degree. And then because we are operating in 180 degree mode, so for how much duration it should continue? 1, 2 and 3. Okay, so it will continue to conduct for 180 degree duration. This is clear to you? Okay. Similarly, so in 180 degree mode of operation, each of the switches are turned on in the interval of 60 degree, and once they are turned on, they continue to conduct for 180. Okay. All these are electrical lines. Similarly, we have 120 degree mode of operation. So in 120 degree mode of operation, again 6 switches are there. So each switch will be turned on in the interval of what? 60 degree. You see that? Each are turned on in the interval of 60 degree. Okay. And but this time they will continue for how much degrees? 120 degree. Because this is 120 degree mode of operation. Okay. Remember that if a inverter is there, depending upon how many legs are there, maybe we have 3 phases, maybe we talk about 5 phases, maybe we talk about 6 phases. So accordingly, you will have modes of operation. Like 3 phase has 2 modes of operation. If you go for 5 phase, you will find 3 or 4 modes of operation. Okay, increase the phase and then you will get the modes of operation. Different modes of operation. Okay, so that is another thing, but we are concerned with this, and that is sufficient for you. So actually, for our requirement, what is there? We work with 120 degree mode of operation. What is that? We have a back EMF. You see that I am starting from the flat portion of the back EMF. Okay? Here you see. So flat portion is starting from time t equal to 0. Time t equal to 0. So actually this is our requirement. We are starting from this position. So this is the back EMF. Back EMF is starting from here, then transition, and then flat portion and this one. What is this point is? This is minus E, and this one is plus E. What the current you are injecting? Plus I, and this one is, okay, this is minus I. Okay, this is the requirement. So we see that for us, which is important, like we see that 120 degree mode of operation of a voltage source inverter is required for us. Why? Because here you have a back EMF which have the flat portion duration what? From here to here. You see, from here to here it is 120 degrees. It is there. Okay. So here 120 degrees. So 120 degree flat portion. Here also 120 degree mode of operation. We need to inject for 120 degree duration. So the current is also, when the switch is on, this switch is on, S1 is on, a current will come like this. Positive current. So positive current. This is say positive current is this. So this is high. And where the negative, this is the negative current. So when it is coming, you see that switch 4 and this is 3 and 4 are operating here. You see that? In this case 3 and 4 are operating. Where is the 3 and 4? This one and this one. So you see that 3 is next phase. But what is for phase A? For phase A, 4 is there now. It is not on. It is finished here. So you see that the negative current is there. So that's why this is the negative current. Okay. So this 120 degree mode of operation is sufficient for us. So what we do, that we have, and what the information we are having. You remember that what is the, these are the Hall states. So these are corresponding to particular Hall state. 6, 1, 2, 3, 3, 4 like this one. So let me show you this diagram. So what is the first Hall state? 1, 0, 1. Let me write here. So where to write? Can I write here? Here I write, huh? नीचे लिख देते हैं. So what is the Hall state? Here it is 1, 0, 1. Okay. In 10161 was operating. You see, please here. So what are the switches operated here? Here you see that. This is what the switch I have told. Okay. So what is operating here? Here you see that it is 101. It is 6 and 1 is operational. 6 and 1 is operational. Then here 1 and 2 is operational. Then here 2 and 3 is working. Then here 3 and 4. Then 4 and 5. You see that? 4 and 5. Okay. And then 5 and 6. 5 and 6. And we are starting from here. Remember that the diagram? We are starting from this position. And so our back EMF is starting from here. Phase A back EMF is starting from here. Then the transition is there. Then phase up till this one. And then phase B back EMF. And then it is there. Okay, here up till this. And this will go up next cycle. So from where it is coming? It is this portion continues. Similarly for phase B, let's say that this is the back EMF. And the transition is, you see, yeah. So, okay. Transition is there. Okay. Then it continues like this. This portion is here. Similarly, phase C. So this is the transition. So I am drawing this again and again so that you should be used to of this. So maybe in the examination we will ask you that okay, draw the waveforms for the phase back EMF and the currents and Hall sensor. So that's why I am drawing again and again. So you see that all the back EMFs are drawn to us. So we know now that relationship, that this is the Hall state known to us, is 101, 100 like this, and then the currents which are to be injected and the relationship between the back EMF. So everything is known. Okay. So can I write here there? This is 101, 100. So this is 101. This is 100. Then what is coming? Hall state 110. Then here 110. Then 010. 010. Then 011. It is 011, and the last state, Hall state, you see it is 001. Okay, it is 001. Now, so you see that all these 6 states are known to us. These 6 states are now known to us. We know the back EMF, we know the switches, what are to be turned off. Now what we have to do? We have to generate the gate first. Because which is the information? Hall state and nothing else. So now you remember and or logics, you remember? Because we have studied in class also. I don't know whether now we have studied or not. But we know and or. And if the two inputs are present, output will be present. Not if input is high, output will be low. Nor if either of the two is present, output will be here. Okay. So now let's learn how to generate the gate signals. Everything we are knowing, but we have to generate gate signals. Then only we will be able to give the switching pulses. Otherwise we will not. So learn that one. Let's. So now, okay. So let us consider that we are having 3 Hall sensors. Okay. Let me draw here. Hall A, Hall B, and then Hall C. Let's say we write here, this is Hall A, this is Hall B, and this is Hall C. Clear? Now, how many Hall states are there? 6 Hall states. So let's say 110. Okay. So it means if all the 3 inputs are present, then only you will be getting high. Okay. So we have to draw 6 AND gates. 6 AND gates. So let's draw. This is 1. Then this is 2. This is 3. This is 4. This is 5. And this one is 6. Okay. So let us see here what we have written. Here we written 101. Okay. Write down here 1 0 1. Second one, what? Second one, it is 1 0 0 1 1 0 1 0 0 1 1 0, then 0 1 0 0 1 1, 0 1 0 0 1 1, then 0 0 1. Okay, 0 0 1. So AND gate, we know that if we are having AND gate, so we know that in AND gate what happens, if let's say the input A and B is there, A and B is there, if both are high, if A is let's say 1 and B is also 1, then C, output C will be what? 1. If A is 0, so A is 0 and B is 0, both are 0, then output will be what? 0. If let's say that A is, I am writing in the top, A is 0 and B is 1, output will be 0. So you know this logic. If either of them are 0, then it will be 0, and if all of them are high, then output will be high. So you see that it needs to get high what? It is, hall A is high, so take it 1 and connect here. Hall B is low. So how to make low? Connect a NOT gate and then make it low. So when it will be high, here you will see a low. Okay. Similarly, hall C is high. So whenever this one will be there, so what are the switches to be operated? This is one of the hall state. So which switch is to be operated? You see that 6 and 1. Okay, 6 and 1 switch to be operated. So you please write down here that the output, this will select switch 6 and 1. Okay. This is one of the hall state. You can write H1. Okay. You can write here that this is hall state 1. H1. Okay. Similarly, now this is 1 0 0. So from where you will get 1? You can take from here 1 0. You can take this one, and this 0 you can make. Okay. So this is what? This is second hall state 2. And in this case, which is the switch to be operated? 1 and 2. Clear? Then we have 1 1 0. Where is 1? This is 1. Okay, then B1 we need, and C0 we need, and C0 we need. Just we are connecting, you see. NOT gate means what? If let's say this is a representation of a NOT gate. If it is A, output will be A bar. Means if you give here it is high, you will get low here, and if it is low, then you will get high here. Okay, so that's why you see that. And so this is which state? This is hall state 3, and which is to be operated? This is 6 1 1 2, then it will be 2 3. Okay. So and then this one hall A is 0. So where had we made any 0? No. Let me make 0. And hall B 1. Where is 1? Hall B here we have taken 1B 1, and hall C 0. See this line. This was 0. So I am just taking from here. Okay. Make it properly and get done. So this is our hall 4. So this is 3 and 4. Similarly, this is 0. Hall A is 0. So just we have made hall A 0. So hall A is 0. Hall B 1. Where is hall B 1? This is hall B 1. Okay. Where is hall C 1? Is there a hall C 1? Yes. This one is this. See? Either you take from here or directly you connect from here, no problem. Okay. Hall C1. You can take directly from upside or you can connect from here. So because we are connecting for all the cases from the upside, so where is hall C? Hall C1? Had we taken? Anywhere? This is the hall C1. You see? Here we have taken. So you can take from this point. But at your level, because you are not directly from the circuit branch, so you can directly connect from here. Okay? Wherever NOT is there, connect the NOT gate and connect. First C. And then this is our hall state 5, and this is 4 and 5. And then next is 5. You see this one? This is 0 0. So where is hall? So just for you, like I am connecting here. So hall A is 0, so you can directly connect a NOT gate and connect it 0. Hall B is 0, so you can directly connect a NOT gate and make it 0, and hall C is 1, so you can connect. So this is what I am saying. Okay, either you connect like this or you connect like this. If you are from the circuit branch, then definitely I will ask you that, okay, make it properly. But you are from mechanical, so you can do it. At the end, it should work on. Huh? So this is done. So this is your hall 6. And what are the switches? It is 5 and 6 switches. So you see that all the hall states are selected. But you see that what is happening? That you are getting the information that when the hall state is there, then you need to operate select 6 and 1. Then 1 and 2, 2 and 3, 3 and 4. Like this is done. But you are not getting clear information that whether it is 6 or 1. So how to do it? So for that we need to select get a OR gate. Okay. So OR gate is what? In OR gate, let's say that what is common. So if the two signal have something common, then what will happen? We will get some output. So in this you see that 1 and 1 is there. So if you make the OR operation with this, okay, OR operation with this, so what will happen? What is common here? 1. So you will get here 1 selected. Got it? है ना, यहाँ पर 1 कॉमन है ना, ये देखिए, this is 1 and this is 1, so you will get 1. Means either of the two is 2 present. Either 6 1 is present, you will get, or 1 2 is present. So what is common? 1. So 1 will be output. Similarly, in this case, you can take the OR operation. Sorry. So hall 2 state and hall 3 state. So what is common? 2. So you will get the 2. Then here hall 3 state. So take this one and take this one. This is 3. Then again between 4 and 5, sorry, this 4 and 5, take the OR operation like this and you will get the 4, because 4 is common. Here this is 5 is common and one more is left, 6. So this and first one. So remember that when you connecting, make a solid line so that it should not, you will not get confused. Okay, like this. It means a dot here means you are getting the connection from here, and it is passing over it. It means that it is not connected. Okay. So it is clear to you that what? So now we are having 6. So you see that we have the information of hall state, and then what we are able to do? We are able to identify that what are the switches to be turned on. So when this 101 will be there, this 61 will be operated, will be on. Means you will get a high signal like this for A. Similarly, when 101 and these two will be there, means 100 will be there, you will see that you are going to get the switch 2 and switch 3. So you are able to identify the switches which are to be given a signal so that they can become on. So whenever you will get a signal, let's say high signal for switch 1, means whenever the corresponding hall state will be there, then what will happen? Automatically switch 1 will be given a signal, this driver's gate signal to get turned on, and the switch will be on. Clear? So these are the signals. Okay, so these are the signals which you give to the switches. Okay, so we can write here, this is switch 1, this is switch 2, this is switch 3, this is switch 4, this is switch 5, and this is switch 6. So switch selection is done. So this process is called selection of the switches. This is called selection of the switches. Selection of the switches. Now, let me go ahead. So you see that now we are in a position, now we are in a position that we have selected this, generated these gate pulses. The switch signals which are to be given to the 6 switches. Okay. Now the situation is something. So what you are doing now, important thing is that here, you please observe. So these signals are given to what? These switches. Remember that each switch is having a driver circuit. Okay, a driver circuit will be there. Let me make it wide with white. Each of the switch will have a driver circuit. Each of the switch will have a driver circuit. So you are giving your gate pulses to these driver circuits, and this driver circuit is connected to the gate and then this point, gate and this point. Okay, and then come on this one like this one. Okay. Similarly here and here. Miss every switch will have some driver circuit. So these signals, these are just a signal, high or low signal. So these signals will be given to this one, this one, this one, this one, this one, this one, this one. So wherever their turn will come, they will turn on. Okay. This is clear. So actually by that way we have generated these signals. So you see that each are shifted from each other by 60 degree. Each are shifted from each other by 60 degree and continue to conduct for 120. So this is called synchronization. Okay. Means now the switch selection is synchronized with the rotor position. Means it is synchronized with the back here. Okay. If you don't do, you will not get maximum torque current here. And maybe like you will not be able to run your motor. Okay. This is only for the synchronous machine. Clear? Okay. Now, so how many switches are conducting? Please let me know. Let's say that here 6 and 1, 1 and 2, like these are operating. Okay. So, let me copy one. Let me copy this diagram to another page. So we know that what is happening, that we are working with 180 degree mode of operation. Now can I remove this because these are not resistors? Okay. So in place of this, what I am doing, just I am making R, L and E. R, L and back EMF. R, L and back EMF. This is EA, this is EB, this is EC, and plus sign is there. Okay, and inside the symbol of the trapezoidal will be there. You have to make this type of symbol inside. Okay. Done. Now let us consider that one of the case. So what is happening here, that you have this arrangement. Make it proper, huh? So you see that this is connected to switch what? 1, this is 2, this is 3. Then this is connected to switch 4, this is 5 and this is 6. Check. 3 and 6, 1 and 4. At a time, how many switches are conducting? At a time, 2 switches. You see, remember that how many switches were conducting at a time? 6 and 1, 1 and 2. Okay, here you see that 6 and 1, 1 and 2. So in one particular Hall state, only 2 phases are going to conduct. What are the switches on? Switch 1 and switch 6. Means positive current is coming from here and then current is outgoing from here. Means current will come like this. Okay, it will go like this. Okay, it will go up. It will come down. Okay, and then it will go as like this one and it will complete the cycle. Okay, only 2 phases are conducting. So here you please see that in this case how many phases are conducting? Only 2 phases are conducting, and this is not in conduction. So you have only one phase. Let's say that this is current come like this, it goes like this, it goes like this, Okay, it goes like this. Then phase B, it goes up. Then 6 is also on, so it will go like this, like this one, and then circuit will be completed. Okay. The circuit is complete. So only 2 phases are conducted. Now tell me one thing. Now when here you see that when this is on, so what is the voltage of this point with respect to negative terminal? When the switch is on, what is the voltage of this point? कोई बताएगा? Anyone? Let's say that this voltage is VDC. So when this is on means what? If this point and this point are connected. VDC. So this point voltage will be VDC with respect to what? Negative terminal of the battery. And this is also on. This is also on. So tell me that what is the voltage of this particular point? 0. Yes. This is 0 with respect to what? A negative terminal of the battery. So this point is at VDC. This point is 0. So what is the voltage? Is this point, between these points. VDC, this is A and this is B. So because 2 are symmetrical, so how much voltage will be there in per phase? Unequal. So here to here voltage will be what? From here to here it will be VDC by 2. VDC by 2, and here to here also it will be VDC by 2. Okay? Clear? So can I write here that BAN is equal to VDC by 2? Equally divide हो जाएगा ना ये voltage? ये दो ही phase conduct कर रहा है ना? VDC by 2, and this one from where we are measuring? We are measuring from here to here, means BNB we are measuring, that is VDC by 2. Check. हाँ, तो BBN कितना होगा? Minus VDC by 2. So आपके what is happening that you have a back EMF, let's say for phase A, you have a back EMF, and how much voltage? What the voltage you are applying? You are applying a voltage VDC like this. VDC by 2. Okay, what is this voltage? This is VDC by 2. This is 0 level. And here you are applying how much voltage? Here also you are applying VDC by 2. This is minus VDC by 2. VDC by 2. And this is what? Plus E. And this one is minus E. So the situation, what you have done? You have applied a fixed voltage across the phase. है ना? तो ये जैसी voltage आपने apply किया, this voltage you have applied, so the current will flow like this. What? You see that the actual current should be like this. है ना? Current will be like this. This is your I. So this line is plus I and this line is minus I. Okay, ऐसे ही रहेगा ना? Because everything is synchronized. नहीं रहेगा, करंट तो ऐसा होने वाला ही नहीं है. करंट तो ऐसा नहीं है. क्यों? करंट फ्लोइंग फैक्टर. Clear? So we are applying this voltage. एक बात बताइए, we are applying this voltage VDC which is synchronized with the back portion of the back movement. So what will happen? Do you think that motor is able to run at a variable speed? मोटर नहीं रन करेगा ना? अगर आप एक फिक्स वोल्टेज अप्लाई कर दीजिए तो कांस्टेंट स्पीड पर रन करेगा, है कि नहीं? वेरिएबल स्पीड पर रन नहीं करने वाला है, तो अगर इसको वेरिएबल स्पीड पर रन करना है तो क्या करना पड़ेगा? What we need to do is we need to run this motor with variable speed. क्या करना? इसका इक्वेशन मालूम है ना क्या हो रहा है? हम लोग क्या इक्वेशन लिखे थे? दिस इज R, this is L, and this is back EMF EA, and this is neutral point. And where you are applying the voltage, this is the negative terminal of the battery. Here you are applying VDC by 2. Sorry, यहाँ से यहाँ तक का वोल्टेज, दिस वोल्टेज इज वी डी सी बाई टू. तो इक्वेशन इफ यू वांट टू राइट, and this is I, so what will be the equation? Tell me. This is VDC by 2 minus I A R phase A है, then minus L DIA over DT minus EA minus 0. Why? Because we are measuring with respect to Newton, है ना? So this is equal to 0. So you please see that what is happening with the current here. What is happening with the current? It is VDC by 2 minus EA is equal to L DIA by DT. यही करंट है. हम लोग क्या कर रहे हैं ना, वी आर नेग्लेक्टिंग द ड्रॉप अक्रॉस दिस रजिस्टर. एक और मैं आपको दिखाता हूँ थोड़ा सा, मजा आएगा. ये हम लोगों ने क्या लिखा, बी डी सी बाई टू माइनस ई ए इज इक्वल टू एल डी आई ए ओवर डी टी. हम लोग इसको ऐसे लिख सकते, कैन वी राइट इट लाइक दिस, डी आई ए ओवर डी थीटा इंटू डी थीटा ओवर डी टी लिख सकते हैं ना. वी आर एबल टू, डी थीटा बाई डी टी इज व्हाट, इलेक्ट्रिकल स्पीड. सो कैन वी राइट इट लाइक दिस, वी डी सी बाई टू एंड व्हाट इज ई ए. ई ए भी रहने देते हैं बैक ही मैम ऐसे ही. And then here you see d theta by dt is electrical speed L d IA over d theta. सब कुछ if everything is constant, then we will not be able to calculate the speed of the motor. d IA over dt तो वेरिएशन कर रहा है, ये करंट ऐसे चेंज कर रहा है. Just I finished because time is over. So here you see current is at this instant we are starting our current. So current will rise like this. For the time we are making like this, we are not making any changes, and then current will rise like this and then it will go like this. So this di over d theta, what we are talking about is this slope of this one. This is IA. So ये slope का बात कर रहे हैं हम लोग, ठीक है. And then speed of the motor is what? Electrical speed. You can get mechanical speed also. So if this is constant, so you can write electrical speed equal to VDC by 2 minus EA divided by L DIA over theta. So अगर if you don't change this one, the speed will remain constant. So change the speed, what we have to do? We have to change this one. Okay, and how we can change it? We can change this definitely if we start modulating this switch. याद है मैंने आप लोगों को पावर इलेक्ट्रॉनिक्स से बताया था कि इसको ऑन ऑफ करने लगेंगे तो व्हाट वाज द वोल्टेज, डेल्टा वी डीसी. यही डेल्टा वी डीसी. So if you do like this, like whenever the switch upper switch turn will come, you make it modulation. And whereas you keep the lower switches on wherever their turn comes. Okay, so what will happen, the voltage of this point will become delta VDC. Okay, so this point will be delta by 2 VDC. Okay, delta VDC, this is delta VDC by 2. So this point will be VDC. Okay, but what you are doing, you are now modulating it. You are now modulating it. You please see, है ना. तो इसका एवरेज वोल्टेज ऑफ दिस वन, लेट्स से दैट दिस इज द एवरेज वोल्टेज. सो दिस एवरेज वोल्टेज विल बी डेल्टा वी डी सी बाई 2. ओके, बताया था मैंने एवरेज वोल्टेज डेल्टा वी डी सी वही है. और इसी तरह से हम लोग क्या कर रहे हैं, वी आर मॉड्यूलेटिंग दिस पोर्शन ऑल्सो. तो अब नाउ एवरीथिंग इज इन आवर हैंड. यू सी, दिस इज इन आवर हैंड. This is in our hand, delta VDC. So we will vary delta, and by this way we will be able to control the speed of it. So now after the examination we will discuss about like what are the methods for the okay. The system what we started. So we have to discuss the control. So there will be current control and the voltage control. So we will want to discuss that. If I want, I can type it all here. So for examination purpose, only up to this one. This is recorded. I will say everything. This lecture is recorded. Huh?